All right, so let's go ahead and simplify this expression here. Let's do an equal sign. And what was the strategy? It was to simplify each term, right? And once we simplified each term, we combined it any like terms, right? So we're going to do a prime factorization of 16. So I'm going to get 2 square root. And 16 is even, so a 2 is going to be what I pull out in the beginning. So 16 divided by 2 is 8. And 8 is even, so I can pull out another 2. That leaves 4, right? 8 divided by 2 is 4. 4 has two factors of 2 times 2, so I could do that. Okay. And then I could double check. I say 2 times 2 is 4, times 2 is 8, times 2 is 16, right? So I did that right. And then I'm going to do my next ones. I'm going to do 5, and now I'm going to find the prime factorization of 200. So 200 is even, so I'm going to take out a 2. That leaves me with 100. 100 is even, so I'm going to pull out another 2. That leaves me with 50. 50 is even, so I'm going to pull out another 2. That leaves me with 25. And 25 is a perfect square, so it's 5 times 5, right? And then we could double check. 2 times 2 times 2 times 5 times 5 does equal to 200, right? And then we'll do 50. So we'll say plus 5 square root 2 times 5 times 5, right? 50 divided by 2 is 25, and 25 is a perfect square. It's 5 times 5. All right, then we'll go and do 100. So we'll say plus the square root of 2, that's 50, divided by 2, that's 25. 25 is a perfect square, so we have 5 and 5. All right. So now we're going to go back and look for our pairs that we can pull out of the square root. Well, I got a pair of 2's there, I got a pair of 2's there, a pair of 2's there, and a pair of 5's, a pair of 5's, a pair of 2's, and a pair of 5's, right? So here I'm going to pull out a 2 and a 2, so it's going to be 2 times 2 times 2, nothing left under the square root, plus 5 times 2 times 5. I'm pulling out the 2 and the 5 out of the square root, and that leaves me with the square root of 2, right? This poor little 2 is left behind. And then we have a plus 5 times 5, and then the square root 2, again, 2 is left behind. And then over here, we're pulling out the 2 times the 5, and nothing is left behind. So this is what we get. Let's go ahead and simplify it a bit more. We got 2 times 2 times 2, that's 8, plus 25 times 2 is 50, square root 2. Here's going to be a 25 square root 2, and this last bit is a plus 10. Right. So now we go ahead and look, and can we combine any of the like terms? Well, these two here don't have a square root, so we can combine them. They're both constants, and we get 18. And then these two are like terms because they both have a square root 2. So we have we're going to add them together, and we get plus 75 square root 2, and we're done. Right. This one down here is a little bit more complicated because now we need to apply the quotient rule. So let's go ahead and do that. Let's first start by simplifying the 12. So it's 2 goes into 12, leaving a 6. 6 is 2 times 3, so that's the prime factorization of 12. And then plus, and here we need to use the quotient rule for square roots. So it's square root of 1 over square root of 3. And now to simplify, we want the denominator to be a rational number, so we're going to multiply by 3, square root 3 over square root 3, like we did in the previous chapter. And so let's say that's equal to, and I'm going to pull out a 2 on that square root, so I get 2 square root 3. And then I'm going to say plus, and then fractions we multiply straight across. So square root 1 times square root 3 is going to be square root 3 over square root 3 times square root 3 is just a positive 3. And so now what can I do? Well, now I could say 2 square root 3 plus 1 over 3 times square root 3. Right, because that's what this is. This is 1 over 3 times square root 3. And so what can I do now? I can go ahead and factor out my square root 3, because you see this term has a square root 3, this term has a square root 3, right? They're like terms. So I can add them, and I'll get 2 1/3 times square root 3, and that's my final answer.